Hello, and welcome to our Chapter 18 practice problems. So I'm going to be going through this. It's going to be at least 3 or 4 videos, so let's get started. So we start off our Chapter 18 practice problems with some true-false, and I want to state that some of this stuff, there's an extra PowerPoint that is up on there that was gone over before class, and on there has the chart that breaks down what type of measurement association you use with different types of study designs, i.e. if you have experimental or cohort or case control, all those. So that will be up there for your benefit, and that's where some of this stuff will come from, in case you're wondering, because I don't think the book does the best job for it. So moving on. So we start off, number 1 is the chi-square analysis provides research with a specific estimate of overall significance for the relationship between outcome and categorical exposure variable when there are more than 2 categories. But in order to assess the individual relationships, researchers should calculate individual risk ratios, and this is true. True. And then number 2, is there a direct relationship between chi-squared and the standard normal distributions whereby the square root of each chi-square statistic is mathematically equal to the corresponding z statistic at significant level alpha? That is also true. You can find both of those in the book. Moving on to our open-ended questions here. Investigators are interested in the relationship between maternal depression and bacterial vaginosis prior to delivery. In order to assess the relationship, the researchers attended a prenatal clinic in New Orleans, Louisiana, and invited women to attend the clinic to take part in a thorough questionnaire about their pregnancy status. Women had to be in at least the second trimester of their pregnancy, and after the questionnaire, the women were required to undergo bacterial culture examinations to confirm their BV status. Data from the women was collected, and the mothers were categorized as exposed, either depressed, or unexposed and not depressed, based on the results from the questionnaire, as well as diseased BV or non-diseased BV negative, based on the results from the culture analysis. So the first question is describe the study analysis, or describe the study to its sampling method. So if you look, it's after the women took this questionnaire, they were required to undergo a bacterial culture examination to their BV, and then they were based on if they were depressed, non-depressed, diseased, and non-diseased. When you do that, this is going to be a cross-sample, or a cross-sectional. Sampling method. And when you have a cross-sectional sampling method, you can either have an odds ratio or a relative risk. So it describes the risk measurement. This is going to be an odds ratio or a relative risk that you can use. Number 4, investigators are interested in the association between serum vitamin D levels and various birth outcomes. Recruited pregnant women to have their blood drawn during the second trimester of their pregnancy. Mothers were then followed until they gave birth. The health outcomes were compared among mothers with low, adequate, and high vitamin D levels. Describe this study to its participant sampling method. This one, the key word here is mothers were followed until they gave birth. So they had to be in the second trimester, and then they were followed until they gave birth. When you do this, this is going to be a cohort. And then when you have a cohort, the most popular one that you're going to use based on the chart is going to be a relative risk. You can use a hazard ratio, but the book doesn't talk about that. And you can use an odds ratio only if there's logistic regression involved within the cohort. So majority of the time, you're going to be seeing a relative risk. Number 5, in order to investigate the relationship between dietary afflictions and hepatocellular carcinoma, all cases of liver cancer developed in the past 5 years, and liver cancer-free controls selected from the pre-existing study cohort at the time of diagnosis were included in the analysis. The exposure of the interest afflictions were assessed from dietary recall questionnaires collected from the subjects at the beginning of the study. So this one's a little tricky, I think, because it says the word cohort in here, but it's not a cohort study. Cohort is just another term for people, like a group of people at a particular time. So if you start at nursing school, when you start nursing school, that is your cohort. You know, when you go to high school, your cohort is your class going through that next 4 years. That is your cohort. So a group of people at that time. So what they're doing is they're finding the group of people who had developed liver cancer in the past 5 years, and then they're matching them to people who were liver cancer free as the controls. So you have a case and controls in the thing, so this is a case control study. And then it says describes risk measurement. When you have case control, you're going to be using an odds ratio. Once again, if you're wondering how you have the case control and odds ratio and cohort and relative risk and all this stuff, once again, that's in that for the extra PowerPoint that's supplemented besides the regular one with the videos that has a chart on there that will explain which ones go to which study. So moving on to number 6, researchers are interested in relation to the family history of Alzheimer's disease and early onset of senile dementia. The study design team decides that they will recruit patients from their database based on their performance on the mini mental state examination, the MMSE. Those that meet the threshold for dementia of the outcome will be actively recruited and frequently matched to 2 controls. So that's the key here, matched to 2 controls with normal memory. Performance on the mini mental state exam, exposed history database on family history, background check will be recorded, and the following table represents the hypothetical result from the experiment. When you read that they're going to be matched to with case controls, the type of study design you have here is a case control. And as you can see, we have our 2x2 table here, where we have family history is present, no family history is present, whether they have dementia or no dementia present. So our 2x2 table is shown here, A, B, C, and D. Part C says calculate the appropriate risk measure to determine a difference in risk for early onset senile dementia based on exposure. Well, if you have a case control, you're going to be doing an odds ratio. The way the book does odds ratio versus the way I like to do it, which is in that other PowerPoint, and I did talk about it, is I like to say take A times D over B times C to determine your odds ratio. Take A is 121 times your D, 450, divided by 220 times 232. When you multiply these out, you'll get 54,450 divided by 51,040, and dividing those out, you'll get 1.0668 as an odds ratio. So what does this tell us when you have an odds ratio? I'll be doing this throughout the next couple ones, but an odds ratio here, so you have an odds ratio of 1.0688. Oh no, 668. Let me erase that, make it a little bit better. 668. What is it saying? It's saying that if you have family history, of dementia, you are 1.0668 times more likely to have dementia later in life than if you have no family history of dementia, which a times 1 ratio isn't necessarily the biggest ratio, so it's not that high of a risk. Could you say there's a slight risk? I'd say a very, very slight risk, but not anything more. Just like with relative risk, anything at 1 is kind of no association. You can apply the same principles here for odds ratio. This will make more sense with our question number 7. So researchers are interested in the relationship between binge drinking and membership in Greek life organizations on the college campus. Suppose the researchers conducted a thorough questionnaire on random sample of students and compose the following table to display their preliminary results. So you have your Greek life organization, no Greek life organization, whether you binge drink or not binge drink. So this is your 2x2 table, A, B, C, D. First, we're going to calculate the prevalence of binge drinking in each group. So the best way to calculate prevalence is to know what are you looking for. So here we're looking for binge drinking. So if we're going to try to find our prevalence, so in the book we have prevalence or incidence. Our value is going to be your A1 over your N. Think of N as your total that you're looking at. So here we're looking at calculate the prevalence of drinking in each groups. So we have binge drinking here and here for each group, whether you're in Greek life or not Greek life. So you take your value of A, so be 131 divided by the total in that row, and that's 168. Divide those out, you get 0.7043 or 70.43% as your prevalence for Greek life organization. And then for your non-Greek life organization, it's 102. The individuals who binge drink over 252, which equals 0.4047 or 40.43%. 40.47%. Now, next you want to calculate an odds ratio for these. So remember, once again, odds ratio is going to be A times D over B times C. When you do this, for your group, your A is 131 times your, that should be D, I don't know why it says C, D, which is 150 over 55 times 102. Multiply these out, and you get 19,650 divided by 5,610. When you do this, you're going to get your odds ratio of 3.5027. What does this mean? It means that those individuals who are part of a Greek life organization, right? It's always going to be your top part. Those that are part of a Greek life organization are 3.5027 times more likely to binge drink than those that are not part of a Greek life organization. I'll say that one more time. So those that are in Greek life organization are 3.5027 times more likely to binge drink than those that are not part of a Greek life organization. Number 8, and then after number 8, we're going to take a break from this video and start another one. So for this one, we have to create and solve a relative risk example. So on October 29th, 2011, family and friends joined from all over the country to attend a wedding. Out of the people invited, only 238 came, and on their RSVPs, their dinner choice was as followed. 112 chose chicken, 126 had steak, and after the celebration was over, some guests became sick. In fact, 64 of those people who ate chicken became ill, as did 26 of those who ate steak. What kind of study design is this? What is the relative risk of developing disease after eating chicken in relation to eating steak, and what does this mean? So first, we're going to find what kind of study design is this. So once again, these people are sick at one individual time. We're not following over time, and we're not comparing these people to controls or comparing it at this moment. So this is going to be a cross-sectional design. What is the RR, developing disease? So relative risk is going to equal A over A plus B all over C or C plus D. So in order to do this, we have to have a 2x2 table. There's one thing I always want you to remember after everything in this class is you always remember for a 2x2 table, which does a lot of things. If you remember that the disease will always go on top, you will always be great, and then the exposure is going to go on the side. So if you always know disease goes on top, you always know that this is going to be sick, and then not sick, or ill, not ill, whatever you prefer. And then our exposure is going to be whether or not they ate the chicken or the steak. So we know that 64 of the people who had chicken were sick, and we know that 26 of the people who had steak were sick. We know a total of 112 people chose chicken, and 126 chose the steak. So 64 plus the non-sick should equal the whole total of 112, and that's going to be your 48. And you know that 26 plus whatever is going to equal 126, so we know that's going to equal 100. And that is your 2x2 table, whether or not you are sick or diseased. So carrying on our relative risk example, you're going to take 64 over 112, right? Because if this is A and B, this is your A plus B, and the same thing, this is your C and D, so this is C plus D here. So 64 over 112 over 26 over 126, you'll get 0.5714 over 0.2063, which is going to give you a relative risk of 2.7697. That's your relative risk. So what does this mean? Means guessed, I'll write this one out,